All right, guys, so this is section 8.7. This is the difference of two squares. And we'll see where that title kind of comes from in a couple minutes. So just as a warm-up, let's just double distribute. Let's multiply these two binomials. So remember, I take my x in my first set of parentheses and I'm going to distribute that to the two terms in my other set. And we're multiplying. So x times x gives me x squared. X times a negative 3 gives me a negative 3x. Now I'm going to take this 3 in my first set of parentheses, distribute it to both items in my second set. 3 times x is a positive 3x, and 3 times negative 3 is a negative 9. So I did my double distribute. I always want to simplify, so I want to combine like terms if I can. And what I notice is I have two terms that just have x's in them. They are like terms, same variable, same exponent. Add the coefficients, variables come along unchanged, right? Not adding exponents or anything when I add and subtract. If I have negative 3x and a positive 3x and I combine those like terms, what's going to happen? They're just going to go away, right? If I have $3 and then I give you 3, how much money do I have? None. I have 3 pencils in front of me. I take 3 away, no more pencils. So I got x squared minus 9. So what's really cool about this setup is that because of the setup of what's inside those parentheses, I actually end up with just a binomial, right? Which we remember what that means, just two terms. So we've seen a lot of trinomials that we've factored into a double bubble. Now we're going to take some binomials and we're going to use this pattern, but look at it in the reverse, right? So again, take a look. What do you have? I have x squared and I have 9. And then what do I see in the double bubble? And that's how we're going to use sort of this reverse engineering. Let's see how we can go from here back to the double bubble, kind of the reverse of what we just did. So before we do that, we want to make sure that we understand what perfect squares are and what makes a number a perfect square. So if I take a number like 2 and I square it, I get 4. That means 4 is a perfect square because it was generated by squaring something. So if I run through and kind of go over what those perfect square values are, 9 is a perfect square, 16, 25, 36. Where am I getting all these numbers, right? I'm just coming up with them randomly? No, I'm squaring 4. I'm squaring 5. I'm squaring 6. If I square 7, right? Square 8. So these numbers are all numbers that you should be comfortable with. And that if I'm able to recognize them, that's just going to make my work in the next couple sections and even later on in the chapter, or in chapter 9 actually, I'm going to be a lot better at this because I'm going to be able to recognize those values. But remember, you have your calculator. So if you're ever unsure if something's a perfect square, you can check. Okay, so we really just need to know this in terms of the factoring aspect. So if you take a look at some of these first example problems, you see what they look like. Like we said, binomials, right? So we talked about from our warm-up how we're going to see binomials now. That's one of my requirements for this to even be the difference of two squares. I can only have two terms, has to be a binomial. There has to be subtraction in between. We talked about where's this name come from? Difference of two squares. It has to be a binomial, that's the 2. It has to be subtraction, that's why the word difference is there. And both of our terms have to be perfect squares. That's where the squares comes from. So the name itself gives you the 3 requirements. Difference of two squares, subtraction, binomial, perfect square terms. This would be an example of, okay, I see it's a binomial. I only see 2 terms. I don't see the 3. There's a subtraction sign in between, so that makes it the difference of 2, and x squared is x squared, so it is something squared, and 81 is 9 squared, right? So this is kind of just off to the side. This is my thought process. X squared gives me x squared, and 9 squared gives me 81. So both x squared and 81 are perfect square terms. So I have two terms, both perfect squares with a minus sign in between. This is the difference of two squares. So how does it factor? Let me think back to my warm-up. Double bubble, x and x is going to give me that x squared. What's going to give me the 81? 9 and 9. But how is it going to be that I'm only going to get these two terms when I double distribute? Well, if I have one of them as a plus and one of them as a minus, that's going to make my two terms in the middle cancel, my like terms. Let me bring you back to that warm-up. When I had x and x, 3 and 3, one a plus, one a minus, I had this as a result when I double distributed. So if I asked you to factor x squared minus 9, I would know that it would go into this double bubble. X and x, 3 and 3, one a plus, one a minus. It's actually super easy once you recognize the pattern. Let's take a look at another one. Two terms, x squared, 16 is 4 squared. There's a minus sign in between, so here I go. Double bubble, x and x, 4 and 4. One gets a plus, one gets a minus. Let me double distribute. This is my answer. That's it. You're done, guys. That's it, right? Super easy. But let me double distribute to check that I get back what I started with, right? X times x is x squared. X times negative 4 is negative 4x. 4 times x is a positive 4x. And 4 times negative 4 is a negative 16. What happens to my two middle terms? They're the same number, different signs. So when I combine like terms, it goes away. I have 4 bananas. I take 4 away. I got no more bananas. My final answer is exactly what I started with. So it's really cool because you see that pattern and it makes the factoring really easy. So let's try a couple more. Let's see if we get the hang of this. So example 3, 4 is a perfect square. It's 2 squared. X squared is a perfect square. It's x squared. 49 is 7 squared. So I got two terms. Both are perfect squares. There's a minus sign in between. I go right to my double bubble. What am I going to square to get 4x squared? Well, 2 squared is 4 and x squared is x squared. So 2x times 2x gives me that 4x squared. What's going to give me the 49? 7 and 7. What's going to make those middle terms cancel and only give me a binomial? Two different signs, one a plus and one a minus. Let's try example 4. 169, I didn't get to that number on our list because it's kind of high up. So I see that number and I'm like, oh my gosh, I just don't know. Is that a perfect square? How do I check? And this is all the way back to chapter 1. If I do the square root, second, and then my x squared button with a 169 in there, I see that 13 squared is 169. So this is a perfect square. So is 9. 3 squared is 9. So I go straight to my double bubble. What's going to give me that 169? 13 and 13. What's going to give me the 9x squared? 3x, 3x. One gets a plus, one gets a minus. Notice I'm not messing around with the order. A lot of times students are like, well, every single problem, the x has been in the first term, right? And now all of a sudden it's in the second. Don't worry about it. Keep it in the same order you received it in. If you try to move things around, change the order, you're going to completely alter that makeup of that problem. Also, something to keep in mind, any even power is a perfect square term. So again, as a side note, if I were to square x squared, so if I had x squared to start and I squared that, power to a power, oh my goodness, chapter 7 coming back. X squared, I multiply my exponents, is x to the 4th. So x to the 4th is a perfect square term. X squared and x squared is what's going to give me that x to the 4th. And what's the square root of 100? What squared gives me 100? 10 squared is 100. 10 times 10 gives me the 100. One gets a plus and one gets a minus. So that way I get a positive 10x squared, a negative 10x squared, and the middle term cancels. Let's try another one. This one's a little easier, so it's kind of nice. Go backwards to something a little simpler. What's going to give me the x squared? X and x. What's going to give me the 25? 5 and 5. One gets a plus, one gets a minus. This one's always a tricky one because you have a 1 and students don't recognize that as a perfect square. But remember, 1 squared is 1. So that is a perfect square. So this is the difference of two squares. Binomial, two terms, right? X squared is a perfect square and 1 is a perfect square, a minus sign in between. Double bubble, x and x, 1 and 1. One gets a plus, one gets a minus. Now, something tricky for you. I see this binomial. I get super excited. It's a binomial. I see x squared. I see 64, which I know is 8 squared. So I'm ready to go. Okay, double bubble. Wait a second. Is this the difference of two squares? I see a plus sign inside. So, okay, maybe it's no different. I don't know. Let's say I do x and x, 8 and 8. One gets a plus, one gets a minus. If I were to check my answer, if I were to double distribute this back to make sure that I get back x squared plus 64, well, let's see. Let me double distribute. I'd get x squared minus 8x plus 8x minus 64. I'd have my negative 8x and positive 8x cancel. I'd get x squared minus 64, and that is not what I started with. I started with that plus sign. So then students say, oh, I know, just make them both pluses. Go ahead, try it. Make them both pluses, make them both minuses. This binomial does not factor. It's not going to work. Try it. So this is not the right answer because you can see it's not going to get me back to the plus sign. This does not factor, so I write that. Doesn't factor. That is my answer. There's nothing for me to do with that binomial